Yeah, I think we need to have this session recorded. So thank you guys. So I'm going to pick it up from strings. And like I said, there are two ways you can define strings in Rust. One is a fixed length or a fixed string. So in this case, we can have, let's say, name. And our name is going to be equal to a string literal, say, is going, something like that. Now, these are basic string literal in Rust, okay? So basically, this string has a fixed length and it is containing a fixed value. So in other words, you can't add any other, you can't concatenate this string with any other or sort of add its length and all that. If we try to do that, it will fail. Now we have global strings in this. Okay, so this is a fixed. Can have these as fixed length strings or primitive string. Then we're going to see how we can define growing strings. So in this case, we can have later, okay, we can call these a sentence, right? Or we can have these as greeting. Then for us to do a growable string, in this case, a string that we can be able to sort of grow its length, in this case, add some other characters to it, the string is going to take a string object. And in this case, it's basically going to be an array, okay? So we can say string from hello. Now, in this case, we are able to sort of do much with this particular string. So the very first thing we can do is we can push to it. So in this case, we can push a string. In this case, we can go with the world. So that as we print this, if we say print line, and we have this printed out, and we do greeting, then these should be able to display hello world. Okay, so I'm just going to have these. I'm just going to run this right here. Let's see what this is going to give us. Oh, okay, there's an error. So let's see what the error is saying. So string run is a private function. So I just forgot to put this. We're going to talk about function, guys, so don't worry about that for now. We're going to have all that addressed. Then here we have, we're also having an error right here. So this should work. Oh, sorry. Let's try running this and see where the error is coming from. So cannot borrow as mutable. Okay. Okay, so in this case, let's try and have a mutable variable. Like I said in our previous session, guys, any variable you define in Rust, you had, is immutable. So for you to sort of mute its content, you may have to add this keyword mute. So let's see if that is going to fix the error. Awesome. So that just worked. We have hello world. Now ignore these for now. Ignore the warnings for now. We're going to talk about functions in due time. So that is basically how you could do a growable string. You can as well get the length of this string by simply doing greeting.len. And if we try and run that, it should give us the length of the string, in this case, 11. It has 11 characters in that case. So you can do the length of the string. The other thing you could do is What else could, now there are so many things you can do with this. But due to time, I'll not be covering most of it, or a good number of it. But then just know there's a lot these can you can really do with this particular the growing string. The way if you define your string as a growing string, so in this case you can as well check if it is empty or not. So let's see if that function exists. Okay. So that should tell us whether the string is empty. So in this case, it is not containing anything, or it is containing anything. So in this case, the string is not empty, so it just returned false. We can as well check if it contains a certain word. So in this case, let's check if it contains Abel. So if we run that, let's see, okay, the string doesn't contain Abel. So in this case, we have false as the value. But if we went with hello, let's see what this has for us. So in that case, it contains the word hello. So it just returned true in that case. So that is basically it about strings. There's so much you can do with strings, like I said. So just due to time, will not cover much. I shared a book actually that's in our Telegram group, Dev Telegram group. So if you're there, you must have found that. And it has a lot to talk about string in this case. I'll just move ahead to arrays. So in this case, we're going to talk about arrays. Now, let me just bring this in. Array. Then we're going to have these right there. Okay. So that is our arrays. Now, one thing to sort of note while dealing with arrays is the arrays in Rust are fixed, have fixed length. So in this case, it is a fixed list where elements are of the same type. Now, if you're coming from Python background, there's a little bit some difference. But if you're coming from C, C++, this should make some sort of sense to you. So in this case, any array you define in Rust must contain the same data, the elements must be of the same data type, and the array itself must have a fixed length. So in this case, you need to define the length of the array while initializing it. So I can define, let's call these numbers, right? So this is going to be numbers. It is going to be an array that is going to contain data of type I32, and it is going to be of length, let's give it 4 for now. Then we initialize it immediately, so we can have that. So that is basically how we declare an array in Rust, guys. Now this array has a fixed length of 4 elements in this case, as you can see. Now if I tried to add a 5th element right there, that should raise an error. Okay, 1, 2, 3, yeah. So these should be able to raise an error. Let us try and print this out and see what it is going to bring us. So I'm going to use that literal as we saw yesterday. So you realize as soon as I save my file, it is raising this particular error. And in this case, it is saying that it expected an array with a fixed size of 4 elements, but then it found this should be 5, I think. Yeah, but it found one with 5 elements, right? So that is where the catch is. So these should contain 4 elements and the error should go away. Now, if we try and run these right now, you realize that our array is printed down here. Now we can as well try and, in as much as we can't sort of increase or decrease the size of this array, we can choose to change or mutate the elements within the array. Now in this case, we can choose to do num, and in this case, we want to change the element at index 3, so 0, 1, 2. So that should be the last element actually. We're going to change its value to say 45, right? Then if we try to print that array now, we should be able to get, oh, sorry, cannot assign that. So let me have these as a mutable array and see if that is going to solve that. I keep forgetting that, guys. So these are some of the errors you'll also be facing while working on your program. So like I said, if you want to mutate any value, any variable in Rust, you have to use this keyword mute. Yeah, so looking at our array down here, you realize that the last element in a initialized array, that is a 4, was replaced by 45. And in our final array has 45 at the last position. Awesome. So that is basically how you can be able to do that. We can as well check the length of the array by using that .len method. So right here, if we try and run that again, you realize that we get 4. So 4 is basically the number of elements or the size of our array. And yeah, so that is basically it. That is all you can do with primitive arrays. Now, these are primitive arrays. That is all you can do with primitive arrays. You can change, you can get the length, you can change that, but we never got an element. We never got an element at an index, so maybe I'll just show us that. So at this point, you may want to, okay, let me just double this down here. So we may want to show an element at a particular index, right? So apparently our array has 0, 1, 2, 3 index. So we can choose to show the value at index 2. So let's see what this is going to give us. So that gives us 3. So let's see, 1, 2, 3. Oh, sorry, 0, 1, 2. So at index 2, because our index, the counting of our index begins at 0, guys. Please note that. So the value or the element at index 2 is going to be 3 in this case, what we just have right there. Now, what if we wanted to, just like strings, we have a fixed length string, the same case with the arrays in this case, but what if we wanted to sort of do or come up with arrays that are going to be able to grow in length? How can we be able to achieve that? Now that presents us to the use of vectors. So in this case, we're just going to do vectors .rs. My public function right here, I'm gonna call that run to save on time. Then I'm going to have this imported within my main.rs file, that is the entry file to our program. Then I'm basically going to ensure that I call the run function in our main.rs file. Awesome. So let's get back to our vectors file. Now I'm just going to simply copy this because you're still, what we're going to talk about is basically similar to arrays. It's only that this is going to be an array that can grow in length. So instead of having a fixed size like 4, we'll be able to sort of have, be able to push content into that. Now, talking about vectors, this is basically going to, these are resizable arrays, and we're going to be able to add or push to the array, pop, that is remove something from the array, and sort of, change or play around with the size of the array. So maybe I can just put that up there as a note. So right here, for us to achieve this, for us to initialize a vector, okay, we need to use that keyword vec. You realize that it is capitalized vec, and it is going to contain values of type I32. Then instead of initializing it as a normal array, we're going to begin that with the word vec and an exclamation mark or a macro. So that basically means that our num is going to be a vector. So I just went ahead and saved my file. For us to push an element to our array. So you realize in this case, we have 4 elements within our array. And if you can just go ahead and print that out, let me comment this out first and do away with that. So let me just try and sort of print this out. You realize we have 1, 2, 3 within our array. Now, what if we wanted to add, in this case, push an element to this particular array? How would you go about that? You simply need to do num.push. And in this case, you provide a value of type i32 that you want to push within the array. So I'm just going to do 45 for now. And I'll go ahead and rerun the program. Now, in this case, you realize we have 5 elements within our array, with the last element being 45. Now, what if you wanted to show the length, right? The length of our array? That is still possible. You can simply do num.length. If we run that, we should be able to get 5. Okay, what did I do, guys? Yeah, right there, we just got 5. Now, if I were to push 2 elements, right? So in this case, I'm going to push 59. But then, before we can print out the values, let me just get rid of these. Oh, sorry, instead of doing that, let me just have another statement to be able to print the array itself down here that way. So I was saying that before I print these, or I can just do num.pop. Now pop basically removes an element from that particular array. Then if I try and print the array again down here, we should be able to see that the last element within that array should be removed. So let's see what this does. So realize in the first array we had 59, but then in the second we only have up to 45. So that means the pop function basically removed the last element within that array. Okay, let's see if we can be able to sort of view an element at a particular index, if that is going to work. So this gives us 3, an element at index 2, this case 0, 1, 2, that is 3. Yeah, so that works. So basically, guys, the difference with these, sorry, this is not primitive array. These are growing arrays, if I may call them. Okay. So these are growing arrays. So this is basically how you'd achieve all that. Let me just make this change as well over here. Awesome. So that is basically how you do, or you'd define growing arrays and primitive arrays in a nutshell. The other thing we're going to look at today, what was that? Let me see my list. Yeah, tuples. Now, tuples is basically a special type of a sort of an array, but let's see how they operate. Okay, so I'm simply going to bring these in my main.rs file. So right here, so we have a tuple. Sorry, we have a tuple module set up. So now tuples are basically, like I said, the sort of a special type of arrays in that they group together values of different types. Now, like arrays are going to sort of group values of the same data type, right? But if you wanted to group values that are going to sort of contain different data types, then you can do that with the tuples. So I'll just, in this case, do, what should I call these guys? Let me say person, right? So person is going to take type tuple. Now, just like in Python, that is, we define a tuple using brackets. Then inside here, we're going to define the data type that is going to be contained in every index within our tuple. Now, in this case, we can have a string in the first index. Then we can have an unsigned 32 in the second index, right? Then right here, we just provide the values. So in this case, we can do able and 59. So in this case, okay, let me see. Yeah, so we just defined a tuple, and then we assigned it, or we gave it a value. Now, if you wanted to access or the values within this particular tuple, then this is how we'd achieve that. So first of all, we're going to print the first value in this particular tuple using the first curly bracket set in my print line statement. Then the second curly bracket is going to print the second value within our tuple. So how do you access the values within our tuples? You simply do person.0 and person.1. So in this case, you're basically using sort of referencing the index of our tuple. So .0 is basically going to access the name able or the string able. Then .1 or index 1 of our person tuple is going to access this value 59. So let's try run this out and see what's going to be generated. So you realize it generated able 59. So that is basically how we can access the values. But for the sake of debugging within your code, if you're gonna come across this, then you may want to sort of print the whole tuple at a go. So you basically use that literal and then provide the name of your tuple or your tuple itself right here. And with that, you should be able to print the whole tuple or all the elements within the tuple as a whole. So that is basically how you do that. So that is tuple for us, guys. The other thing we're going to talk about now is loops. Let's do loops.rs. Then I'm just gonna do, as usual, my function right here. Then I'm gonna bring this within our main.rs file. Call that loops. Thank you. So right here, we're going to do loops run. Awesome. So back to loops. Now, there are three main types of loops in Rust. One, if you're coming from a C background, in this case, you're a system programmer using Arduino, then you must have interacted with this, so nothing new really. Now, let's have that there. So loops are used to iterate until a certain condition is met. So we're going to talk about the first type of loop, in this case, infinite loop within Rust. Now, like I said, Rust is a system programming language, and this loop is usually of use in system programming languages. Now, loop is basically an infinite loop. So any statement that is going to go within the body of that loop is going to be executed infinitely, okay? Unless you provide some conditions to sort of break out of the loop, which is what we're going to do right now, since we don't want our loop to run all through. It might hang my machine, guys. So I'm basically going to provide some conditions in this case. So I'm going to define a variable right here. I'll call it counter. It should be mutable because you're going to change its value. Then I'm basically going to assign it a value. Let's begin with 0. So right here, we're basically going to print some statements. We can print, we can actually print count, the value of count itself, right? Let's do that. Then down here, we're going to provide a condition. Now we talked about conditions yesterday. We're going to provide a condition that is going to sort of regulate some operations within our loop or the lifetime of our loop. So in this case, we're going to check if counter is greater than or equal to, say 10. If that is the case, then simply break out of the loop, okay? Otherwise, go ahead and increment the value. We can do plus equals. Increment the value of count by 1, okay? Oh, sorry. It's counter. Should be counter. So yeah, that should be able to work, guys. Let's run this and see what's going to happen. Sorry. Oh, sorry. Awesome. So you realize it just printed the elements, that is the counter value, right, from 0 to 10. Okay. So that is one way you can do that. So that is basically an infinite loop. So in this case, it was able to break, we were able to break out of the loop because there was a break statement. Okay. So this break statement is basically what helped us to break out of the loop. Now, the other kind or the other type of loop we're going to talk about is a while loop. So in this case, a while loop in Rust. Now, while loop also will take a condition. So in this case, we're going to have a condition that is sort of going to determine if it's going to run or not. So we can just do while, and in this case, let's initialize the value of counter to be 0. I'm just going to use the same thing I defined up there, guys. But in this case, I'm simply changing its value to 0. Then I'm going to check if counter is greater than or equal to 10, right? Then I'm basically going to copy whatever we have inside here, inside our infinite loop, because just to save us on time. So we have counter, not counter. Thank you. So yes, that is how we do counter. Now, if we come back here and try run that, now I'm going to comment out these guys, the infinite loop, so that we don't have some confusion with the whatever loop you're talking about. Now, in this case, you're talking about the while loop. So I'll just rerun that so that we have the while loop running. So, okay. Sorry, guys. I think I missed my condition. It's not making sense. So our counter is apparently or initially 0, but then we are checking if the counter is greater than or equal to 10, right? So that is not making sense. Let's check if it is less than, right, or equal to 10. So while it is less than or equal to 10, then let's proceed and execute whatever is inside the loop statement, or the loop body. Awesome. So that is what happened. we basically printed the value right from 0 to 10. So we achieved the same thing with the infinite loop. So that is basically how you can go about that. We also have the for loop. For loops in Rust. Now, for loops in Rust, if you're coming from a Python background, then this one is also going to be a breeze for you. So we have a for x in, let's do a range. So a range between 0 to 10, right? So you realize how I define this is, okay, this is how we define range in Rust. This might be a little bit different from Python, but that is basically how we do that. So we're going to basically print the value of x, and let's see how this is going to be a string literal format. Oh, sorry. So we have that. Awesome. Thank you. So if we go ahead and run that, you realize we have, in this case, we have 0 to 9. So basically the value of x that was printed. If you wanted to print up to the value 10, then we would simply need to do provide a range up to 11, from 0 to 11, that is, and you'll be able to do that. Now, I just never commented out the while loop, and that's why you guys can see the sort of some confusion within our output. So let me just redo that, and awesome. So we were able to do that, 0 to 10, printed in our terminal. I really hope you guys are seeing something. If you have any question, please feel free to bring them up so that we tackle them as soon as possible. So that is basically how how loops are implemented in a Rust programming language or in a Rust program. That is basically how you can go about that. Now, how can we use loops within our arrays? So if I can just come back to our arrays, and I'm using the primitive arrays, but you can as well use these within your vectors. So I'm simply going to print every element from our array. How can I go about this? I just need to do F for X, or you can name this anything, guys. So we can name this item. For every item in the array num.iter, in this case, the array has to be iterable. We're going to print that value item. So in this case, I just have to provide this if I proceed, a string, how they're going to be printed out. So that is how we did that. Sorry. I just need to change this from our main file. I'm still running the loops. So if I can now run this again, you realize we have all the values from our array. In this case, our array has 1, 2, 3, 4. Sorry, 1, 2, then the value 3 was replaced by 45 in this case. So we should have 1, 2, 3, 45. Yeah, the value of 4 is what was replaced. So 1, 2, 3, 45. So in this case, that is exactly what you have. So we have 45, 3, 2, 1. The 3 in this case was a value we got from line 12. So that should not confuse you. Let me just bring in some sort of differences right here and say array elements. Okay. So if we save that and redeem, okay, I never provided a semicolon in that statement. So if we did that again, we realize we have now those elements listed perfectly. Now that is it, guys, how you can go about arrays in Rust. So very fast again. If you have any question, please, you can put up your hand, or you can simply put them in the chat. I'll reach out to you. Okay. So please do so. So we're going to talk about, let me see my next topic. We're going to talk about functions now. So let's talk about functions. We've been writing them, but then we still don't know what they are. Sorry, how to go about them. So inside here, I'm going to do my usual function. Actually, guys, I've been writing a function in our program, the pub fn run. That's all. That's already a function. Let me just do away with these ones. So right here, I'm going to bring in my function module. Then I'm gonna comment that out. Then right here, I'm actually going to do functions.run. So now in this case, we're going to run our functions. Now, to declare a function in Rust, you simply need to, just like in JavaScript, you would come here and do function, give it some name, some parentheses, and the curly brackets and such. Now, with Rust, you don't need to write all that word. You just need to write fn to indicate that that's a function. Okay. So by default, this function is private, but it has a private scope. Okay. So it's private to this module, in this case, functions.rs. So function.rs is a module within our project, and within it, it has a function called name, but then this function is private. So you can't access this function outside this particular module. Now, for us to be able to access this function outside this module, we would have to prefix it with the keyword pub to make it public. That's why, guys, all the functions I've been writing so far, our run function, what I've been using in our main .rs file, has always been prefixed by or we have the keyword pub coming first before proceeding with the function definition. So that is basically how you want to go about that. But for now, we're going to use the functions we're going to define are going to be used within our file. So there's no need of using the public keyword before them, before the declaration. So in this case, we're going to write a function. Let's call it the greeting. And in this case, our function is basically going to print some string, in this case, hello there. Yeah, something like that, as simple as that. Now, this is function declaration. We've just declared our function. So how do we invoke this function? Or how do we call this particular function? We'd simply need to come right here and say greeting. So by running that, let's see what happens in our terminal. I really hope you guys are able to see this, and I'm really not obscuring anything from you. So you realize right here, we have a string returned, hello there. So that string was basically executed after invoking our function, okay? Now, functions can as well receive, or yeah, they can receive parameters. So you may need a parameter to be passed to a function. How do you go about that? In your function declaration, you just need to provide the parameters up there. So in this case, we may need a name. This name is going to be of type string. So it can take type string, basically a reference to a string that is going to be provided. Then in this case, instead of just saying hello there, we're going to say hello there somebody, or hello there a name. Then we just provide that name right there. So in this case, we realize there's already an error showing in my IDE due to the IntelliSense I told you about yesterday, guys. So I'll just provide the name Abel. Again, in this session, I'm going to use Abel for some time. I really hope, Abel, you don't mind. Yes. So in this case, instead of just a string hello there, we printed a string hello there with the name that we provided as an argument to our function, in this case, Abel. And so it printed out hello there, Abel. So that is basically how you want to go about parameters, and you could provide as many parameters as you want, guys. You're not limited to just some sort of simple or certain parameters within your functions. Now, the other thing I really want to talk about now is functions that return some sort of data. So in this case, we may want to accept, let me call these, what should I call these, guys? Okay, let me say show. Let's use the name show. In this case, we're not going to print anything within this function. We're just going to return, a string value, okay? And I really want you to be keen and careful while defining return type, functions that are going to return values. Now, to indicate that this function is going to return something, I use this particular symbol, the spread symbol. Then I provide the data type of whatever is going to be returned. In this case, I just need a string to be returned, right? Yes. And then I'm basically going to use a growable string. So I'm simply going to have these right here. I can do hello. Instead of doing hello there, I can just do hello. Then down here, we can have this stored in a variable, guys. So let's have it stored in the variable grade. Then here, I'm simply going to push the name that was provided as an argument. In this case, the name argument in our show function. So since you realize, let me just try saving this. You realize that as soon as I save this file, my IntelliSense tells me that, hey, you just said you're going to return something, but then there's nothing returned. So what's happening? So for me to be able to return this particular value, the string value, I simply need to write or provide greet. Okay. So okay, there's a expected. Okay, not that str. Awesome. So that should work. So you realize that for us to return a value in a function, you don't have to end your return value in a semicolon. And you also realize we're not using any return keywords here, okay? We're just doing a greet. So we're basically providing the value we want to return, in this case, the variable greet, without any semicolon following. So really take good note of that. Otherwise, you'll really face some good challenges with Rust and some more with the compiler. So we're going to call this function and see what this is basically going to give us. Let's try and bring that up there. So in this case, we're going to invoke the show function. It is going to return to us a string data type. But then for us to be able to print this in our terminal, we'll have to print the value now from our run function. So I'm just going to store this in, I can call that str. So str is going to be of type string. My compiler just did it for me, but sorry, my IDE. Then we're going to print this, going to print line, and we're basically going to provide the value of what we want to print, in this case, str. So let's try and invoke these and see what's going to print. Awesome. So down here, guys, you realize we've printed out hello Abel. So what we just provided here, hello, then we pushed in the name, and finally returned that particular variable. Then up here, we are getting the value returned from invocation of this particular function in this str variable. And we're basically using that, the value in that variable to print out to our terminal. So that is basically it. That is how we go about function definition and invoking a function in our or in your Rust program. Okay. So right now, I'm going to talk about what we call structs. Again, if you're coming from a C, C++ background, you should be familiar with all these guys. Okay. So you really see how Rust is not out of the blues. Okay. So at least you have something to relate with. Now, let me just do the due diligence. In this case, you're going to have a public function that we're going to use to run whatever we're going to code right here. So I'll just avail that. And then I'll have it imported within our main.rs file, and simply invoke that particular function right here. Sorry. Awesome. Now, talking about structs, this is an OOP concept. If you're coming from these other object-oriented programming languages, and think of structs as a class in those other OOP languages. Now, there comes a time within your program when you do want to sort of define your own data type. In this case, you're sort of coming up with a blueprint of the data type you want to use within your program. And for you to do that, you'd want to use a class where you're going to provide instance variables of that particular class and the methods that are going to be used within that particular class to achieve certain behaviors of an object. Okay, so how do we do that in Rust? So we have this keyword struct that we're going to use. So that is basically, it's similar to what we call the keyword class in other languages like JavaScript, Java, and all that. Okay, so struct, and we're going to give this name. Let's give it person for simplicity. So in this case, we have a person struct. This person struct is going to have some instance variables. In this case, you're going to have a name, and the name can be of type string. Then we're going to have age. Age can be of type U32, right? Then from there, we already have our instance variables of our struct or of the object we're trying to define to give a blueprint of. Now, for us to be able to provide the methods or behaviors to this particular object, this is how we go about it. You use the word, the keyword impl or implement, okay? In other words, so you're going to implement methods for this particular person struct. So the very first method you're going to work to look at is new. So new, think of new like a constructor in a Java program. Think of new like a constructor in a JavaScript program. Think of new as a constructor in these other programming languages, the PHP and the like. Okay. So in this case, new is going to return a data type of type self. So in this case, it's basically going to return a data of this, or a data that is going to take a type of this particular struct you're talking about. Okay, so it's returning itself, in other words. So to return itself, we simply need to do self, then provide, you realize it's requesting for the values of these instance variables we defined up here. Okay, so we can choose to get that from the whatever the user is going to provide us with. So we can choose to get this from a string, say, let's have the name from the user and also the age, right, from the user. So age is going to take U32 data type, and the name is going to take the string, a reference to a string. So that is basically that. So right here, we can simply do name. Yeah, we can do name. Then right here we do age. Okay. Now you realize that there are some underlines there telling me that the string found, but then it found, okay, string with caps S was expected, but then it found a reference to a string. So how can we go about this? Simply need to do a to string. So we basically convert it to the data type we're talking about, okay? Now, there's also something here. I don't know if you can really see the pop-ups I'm showing you guys. Can someone confirm, please? From my IDE, there's a pop-up that has just shown by hovering over letter A in the word age. Can someone confirm, please, if you can see that? Because there's something I want to show us. Okay, thank you. Now, let's read through the message. It's saying that shorthand struct initialization. So it means if you're coming again, if you're so familiar with the JSON, these that is in JavaScript, these should be familiar with you. You should be familiar with this. So instead of us providing age colon age, so both of these things are the same, right? So why don't we just go with one and provide age shorthand for that, right? So that is basically what you are, or what I wanted to show us right there. Then right here we can provide we can provide a function or a method. Sorry, all functions within the struct within a struct are referred to as methods. So they are like the methods of a class in the other programming languages. So in this case, we can say we want a function to load to print print info, for lack of a better naming word. Let's just do print info. So print info is basically going to print. This is going to print, let's see. So these should print name and the age of this particular person we're talking about in this case. So we can say the name we're going to provide is these years old. Awesome. Then we provide our arguments. In this case, you're going to have, now there's something I missed right here, guys. There's something I missed here. Now, those of us who are coming from a Python background, Python programming language, that is, there's this particular keyword you usually use when we write methods of a class. We refer to it as self. So in this case, we're going to provide a reference to self, meaning these it usually comes as the first parameter in all the methods within our function. So this is basically going to qualify this function as a method within this struct, okay? So it will be able to interact with the instance variable of this particular object, in this case, person, right? So I should come here and say self.name and self.age. And that should be able to work. Awesome. So we basically defined a method. Again, guys, I really hope you can see this. So that is basically what we've implemented. Now we want to be able to invoke, sorry, first of all, initialize or create an object out of this data type we've just created, in this case, person, and be able to invoke its method, in this case, print info, right? So let's see how we can go about that. So within my run function, I'm simply going to do to create an object out of this. I'm going to call this person. So person is going to take type person, right? And we're going to do we're going to do person double full colon new, then you're going to provide the name. In this case, let's use someone else, Buru. And Buru, I hope you're not 45. That's just a random number. Okay. We can do away with this now. Okay. Let's see what's happening here. Yeah, that should be able. So our constructor doesn't need to take the self parameter for us to be able to initialize the object. So that is how we go about that. So that by doing that, what I've just highlighted, we've initialized an object. Then we're going to simply, let's print out something. So I'll just store that within, let me call this statement. So statement is basically going to be of type string. Let's use a primitive string. Then in this case, we're going to invoke from the person object, you're going to invoke print info method. Okay, so we expect that this print info method should now print Buru is 45 years old. That is what we expect. Let's see if that is going to be the case. So let's just print that out. Print line. In this case, we provide the statement we want to print. And I just did it wrongly. So let me do this, make the change right there. Did I misspell something? Okay. That should do. What's happening? Doesn't implement. Okay. This should be a string. Oh, sorry, guys. I'm trying to return a string, but then we never return. This function is not returning a string. So let's see how we can return this. So, okay. Well, let's just print it right here instead of going through all these hassle. So our print function should be able to simply print that information once we invoke this particular function to make things clean. So I hope that is quite clear. So I'll just, from my terminal, let me just expand this. Let's try running that and see what's going to happen. So exactly, here's what was printed. Buru is 45 years old. So that string was generated from our print info function right here, where we said we provided all that with the instance variable that was used to create our object. So that is basically how we go about that. Structs, guys. I don't know if there's any question or anything anyone may not have understood. So there's no question. Okay. Now we could also have private functions within our within our struct, within the implementation of our struct. So in this case, I can just okay. I don't know if this will work. That won't work. Maybe I'll present that to us sometimes later as we proceed. We're going to see how we can do that actually once we begin doing the program in Rust. We're going to see how we can use a certain macro that is basically going to define a function as private within the struct. Now, maybe one thing I want to touch on before we just conclude. I know we already passed time, but you'll just allow me touch on this, please, before we conclude. Some sort of three concepts. One is traits. So we can do traits.rs. Now think of traits as interfaces in JavaScript or interfaces in, are they in Java? But they should be, okay? Yeah, so traits basically define a certain blueprint of what an object or a class should take or should implement in that case. So we can just do, okay, let me do my usual power define function first. Then after that, have it brought it in my main function and do more traits. Then do traits. Try. Awesome. So traits, like I said, are basically interfaces. So in this case, we can do a trait. Sorry, can do a trait. In this case, we're going to say we're also going to call this person a person trait. Now, person trait is going to, there are some methods, or I could call this a car. Now, there are some methods you expect any object that is going to take, any object that is going to implement this trait to take. So we can say we can have this method start engine, right? And a start engine is not going to return anything. So in this case, we've basically provided a method that any class or any struct that is going to implement this trait must implement. Okay. So if I were to come here and define, let's say, let's call this Toyota. And Toyota was going to have a name. In this case, we can call that RAV4 for the lovers of RAV4 cars. Oh, sorry. This should be a string first, right? Then in the implementation, I'm going to implement this particular struct, Toyota. And this is going to take, we're going to have the new or the constructor of our struct. In this case, it's going to return self. And you're basically going to return the self object. In this case, it will require a name, and that is what we're going to provide. Let's just give this. It may not be the exact name, but let's just provide it for now to string. Awesome. So that should be able to help us initialize the Toyota object. Then we want to implement this trait, in this case, car. Okay, so for us to be able to do that, this is how we do it. Please take in note on this. We want to implement car trait for Toyota struct. Okay. If I just save that, you realize that my IDE is already complaining because I've not implemented this method yet. Okay. So if I just came right here and implemented the method start engine, okay, and in this case, I'm simply going to print something here, say engine started, right? So that should be good to go. Okay, why is this guy complaining? He's not a member. Okay, this guy should be a member of this method, definitely. So it has to take these. It has to take that first. Oh my, what did we do wrong right here, guys? Huh? Oh, okay, so there's some catch here. So this guy doesn't want to sort of share the same implementation with the function we are trying to implement. So I'll just go ahead and do another implementation, this time for Toyota. So these are basically the methods for this class Toyota, or for the struct Toyota. Then the methods that we are going to implement from the car trait, in this case, the trait we just defined up there, is going to take another or a separate implementation. And that is how we do that. Now, I can simply come in our run function and do, let's call this any car, right? And this is going to do car new. That should be good to go. This should be of type car. Oh, sorry. This should be of type Toyota. Then this should be Toyota new, right? Then we should be able to simply say car dot, what was that? Start engine, right? Yeah, start engine. So once I run this, we should be able to print engine started in our terminal, because we just invoked that function up there. So let's just see what that has to bring. Awesome. So you realize that was just printed, engine started. So we implemented a method that we defined, within our trait. So we first of all defined the trait. Then we came up with a struct. We implemented the method specifically for that particular struct, in this case Toyota. Then down here, we implemented the start engine method that we are pulling from, or that we are expected to implement, depending on what has been defined in our car trait. So I really hope you guys are seeing what's happening right there. And you're really able to brainstorm much on that. So you can, there's a book I posted in our dev group as well. Please go through that. You'll be able to understand all these concepts deeply. You'll be able to understand all these in greater depth. Now, the other concept that I'm going to talk about is enums. Now, enums, as you can think of them, they're just, easy to work with. They make life a bit easier. So let's see how we can sort of, oh my God. Let's see how we can use this. So, okay, I was just doing the initialization to a main.rs file. Then back to our enums. Okay, enums basically provide, now, guys, I hope I mentioned this because there's something I'm going to mention in enums that is simply going, going to bring out some differences between enums and structs. Now back to structs file. You see these instance variables, they are private by default, okay? These instance variables right here are private by default. So I can't come up here and say person.name. Okay, this never raised an error. It never raised an error. But this these instance variables should be private by default, so that if you wanted to use certain values or organize an object that is sort of going to contain certain values that you're going to repeatedly use within your program, then enums will come in handy for that. So in this case, for us to declare an enum, we simply need to do or use the keyword enum in this case. And we can say, let's define a status. Okay, so in this case, this enum is called status. So it's basically going to contain the states that we're going to sort of define within it. So a state could be pending, a state could be active, a state could be completed, right? So let's say those are the states our enum is going to have. So if I came up here and say, let me define just a variable. Let me call this, oh God, sorry. Let me call this state. Then I'm going to give this status. I'm going to give it a state active, the active state, okay? Then down here, we already did conditional, so I hope this is not new to us. So I'm going to check if state is equal to status, the completed status. So if the state is completed, then simply print task complete, right? Just something similar to that. Else, if state is equal to, or in this case, guys, I think our match statement comes in handy right here. So let me just use a match. So in this case, you're going to match state. And here are the values you expect. So we expect status. If it is completed, then simply print this. Print task complete. Okay. If the status is going to be active, then we'll have to print, we need to print task in progress, right? Then if the status is pending, in this case, we want to print task pending, right? I think that makes sense. Okay, if nothing or none of these status was met, in this case, I'm using an underscore. Then in this case, we simply want to print something went wrong. Okay. Great. So based on our enum or the value of our enum, we are able to sort of come up with this. Okay. So if I go ahead and simply run this, our status is apparently active. So it is printing out task in progress. If I were to change this to say pending, that would print out, sorry, let's see. That would print out task pending. Okay. And if, sorry, man. Okay. So if this was something else, right? Something else other than what we stipulated within our match statement. In this case, we can just add none, okay, within our enum. So in this case, we have none. So if nothing matched, then you realize you have something went wrong. So in that case, the very last or the default case statement was executed. Yeah, so that is enums for us. Then, sorry. Yeah, that is enums for us. So the very last thing I'll want to point out, this is what we are tackling last, guys, then we just call it a night. Ref pointer, references and pointers in Rust, okay? If you're coming from C, C++, this should be in majority of programming languages. So you should be as well, should be familiar with this concept. So I'm just going to do our usual function. Then I'm going to have this within our main folder. Mode ref pointer. Then down here, I'm simply going to bring it in. Then we already have that. Now, references is basically you're defining a variable, but then you want to reassign the value of that particular variable to another variable. Now, the concept works if you are using primitive data types within Rust. In this case, I'm talking about the integer data types, the primitive array data type we looked at previously, the primitive strings, so you can easily do that. However, if you're dealing with non-primitive data types within Rust, in this case, the likes of vectors, okay, the likes of the growable string, or any data type you're going to define, in this case, the classes you guys are going to write within your program, you'll have to reference them for you to be able to assign their values to other variables, okay? So in this case, I'm trying to say, if let's say I used, let's say we have a number, let's give this a value 45, and I wanted to come down here and say, I have another, I'm declaring another variable. In this case, I'm calling it age, and I want to basically assign that number to it. That doesn't raise an error. And if I go ahead and simply print the value, so I can basically print the two values that I go. So far, the very first one is going to be, let me show us this first. So I'm going to print age, okay, in this case. So if I run this, you realize that 45 is printed out. So it basically copied the value of num right to the age variable. What if I try to print the value, the variable num? What happens? Let's see. So that still prints the value 45 because these are primitive types, okay? However, if we were talking about the non-primitive types, the likes of vectors and the structs you guys are going to define within your program, then it means the Rust will provide a reference to them. Otherwise, if you try to, just do it direct as you've done right here, then there's an error. I mean, an error will be raised. Let's see how we can go about that. So I can just call these nums again, for lack of better naming conventions. This is going to take I32, but you can take any data type right here, guys. We're just using this for convenience. So this is going to be a vector, and we can go with some random numbers right there. Awesome. So that is basically a vector defined right there. So if we wanted to define another vector, in this case, ages, again, and in this case, I wanted to do nums, right? Nums. So I basically wanted to assign ages to nums. Let's go ahead and print Control C, print ages, and see what's going to happen. You realize that already an error, there's an error displayed right here, but that can be fixed using that literal as we discussed previously. Now let's go ahead and try printing these. Oh, that just printed. So, okay, this basically copied. It basically copied these values. The value of this variable num to the ages variable. However, if you're looking at memory optimization within your program, then that may not be the way to go, right? So in this case, you'll need to provide a reference to the variable we're talking about. Now, there's also, like I said previously, there's the providing or rather accepting a value as a reference. In this case, a reference to our nums variable. It is basically, so our ages variable is going to store a reference to our nums variable. In this case, it is not going to store the exact values of the vector just defined up here, but it is going to store a reference to this particular variable, in which case, whatever operations you're going to do within this variable, it will basically be using these values. Okay, so we don't have to clone or create other copies within the memory of our program. Sorry, the memory of our computer. So that comes in when we talk about memory management. Again, if you're good with programming, you should be able to understand that. So in this case, let's try and print this out. And that, again, prints the values to us, just as we requested. And if you wanted to print the value at index 0, that should as well easily print out that value. So in this case, it is retrieving this value from the value stored in the variable num. You also realize that in my statements, there's somewhere I used certainly, I don't know if it must be function, right? Yeah, right here. So I was accepting a value, but then I was accepting a reference of this value. So in this case, this function is really not taking a string value, but it is taking a reference to a variable of string data type or of type string. Okay, it is taking a reference, and this is how we denote that. You begin your type with an ampersand. So we simply take that reference and use it right here. If I was taking the whole string, then it means after taking that string, I won't be able to use that value anywhere again within our program or out of the scope of that particular block. I won't be able to do that. So that's why I'm only picking up a string right there. And this is the string I'm referring to. So I'm picking a reference to this string and I'm using it within my function, right? So yeah, that is it, guys. I'm going to push this to the GitHub repo, the link I just shared with us in the group. And I hope you guys will be able to follow along in due time. Someone has their hand raised. Yes, Cosmos. Cosmos, please go ahead.
Can you hear me?
Yeah, sure.
So I have a question. It's not actually very related to today, but it's somewhat related.
Okay.
So let's say I'm creating a DAO.
Yeah.
And in a DAO, most people are supposed to be on the same level. Then I want to create maybe a CEO where the members can vote for the CEO.
Yeah.
Which is the best option, an enum or a trait for that kind of scenario, defining whether it's a CEO or a normal member?
Okay. Do you have these positioned hard coded within your smart contract?
I want it to be hard-coded.
Yeah.
In the beginning, everyone is equal, but maybe after voting, they can decide who is going to be the CEO, this position.
So you sort of, okay, you kind of have these positions within your smart contract, right? So you want to have these positions defined within your smart contract, the CEO, yeah. Manager, and all that, right?
And their roles, and the roles to be hard-coded.
Yeah.
For example, if it's a treasurer, the roles are defined on the contract.
Yeah.
Then, but in the beginning, maybe there are no people in that position, so people have to vote for that. That's
yeah.
What I mean.
Yeah, I think an enum would do. An enum would work best to define the positions. Okay. But if you're looking to sort of having an object of those positions, so maybe you want to give roles to the position CEO. So CEO could have some methods to, or could have some behaviors, could do this, and that, and you want them to have certain properties. So that is well presented using a struct. But if you're just looking to go with the positions and just the positions, then I think enums would work best. in that case.
What's the difference? Because what I meant was in a struct, you can define and say the CEO can do this and this, or the treasurer can do this and this. In an enum, you can't do that.
So this is what I was talking about, or what I just explained. If you are just after stating the positions, so you could just do CEO, treasurer, treasurer, hope that is the spelling, and so on. Okay, so you'd give these some name positions. So you'd easily do that. So it's easy for you to simply come here and say positions something CEO, you see. But then if you wanted to give them some behavior, in this case, you want a treasurer to have some functions or some methods, some behavior, okay? I don't know if this is the case with your scenario, but in this case, we may want to define an object, something like that. Then right here, we implement some methods for this particular object. Then here we can say, I don't know if they do this, but you can have a function for audit, right? So in this case, we have a treasurer doing some audits. Now, if you already have these objects within your smart contract, you just need people to assume them. Then it will be, this is how you easily present that. So you already have a treasurer object, you have a CEO object, you have the other positions object. So in order for you to initialize them, you can use enums to as well do that. So you could easily have positions, have CEO, have treasurer. Again, I'm missing these. Treasurer, okay. And then you'd say something like if, and again here we are having the position. Come on, the position equal to position CEO or treasurer. Okay, so down here you're checking if position is equal to position treasurer. You simply want to invoke what? That, or make that particular object. So in this case, you like, let me just call it that. So you do treasurer new, something like that. So that is how you proceed. So in this case, you first check the position. You basically affirm the position of that particular person. Then from there, you create an object based on their position. I really don't know if if that answers your question, Meshach. Oh, sorry, Cosmos.
Yeah, it answers the question. Thanks.
Okay. So just get rid of that. Is there any other question, guys? Anyone with any other question? Okay, can't see any question. So guys, there's an assignment I'm going to give us. There's an assignment today. If you're not in the group, please follow the links that have been shared in the chat by Cynthia. Join the group because I'm going to share a file with us, and I'll also, yes, Brian, please go ahead. Brian, are you able to unmute? Brian, hello.
Hello.
Yeah, hello. You had a question?
Yeah, I had a question. My problem on running
Or
running
Rust in Windows?
Rust on Windows.
Okay.
Problem. Yeah. How can I share the screen and the help?
Just a minute. Let me share this so that we remain with those who are willing to in class, because time has already gone. Really, I don't want to keep us really here that much. So
Okay.
I'm just getting the assignment, guys. I'm going to share it with us in the chat. So let me just do that right now. So it's under downloads. Right here, we should be able to find. Come on. Awesome. So that file is just it's uploading. Okay. Yeah, it has been sent successfully. So you should be able to see that in the chat. That is Zoom chat. I'm also going to post it in the Telegram group, the dev community, so that you find it there. So please attempt that particular assignment. It has all the instructions together with the link where you're going to submit your details after finishing that is. So please ensure you attempt that and provide the necessary details for us to be able to assess it. That is basically going to help you build up your skills and familiarize with yourself. Familiarize yourself with the Rust programming language before we dive into we start the blockchain concepts. Now we're going to start. That is on Monday, because we're not going to have a class tomorrow, guys. So over the weekend we won't be having our classes. That is Saturday and Sunday. So we're going to proceed on Monday, and from Monday we're going to do tests in Rust. So we're basically going to learn how to write unit tests in Rust programming language. Then from Tuesday, we start off with the blockchain concepts. So in this case, how to create a smart contract on the NEAR protocol. I really hope you guys have had, you've understood the concepts we presented so far. If not, please ensure you work on them and see to it that you've grasped something out of what has been taught so far. So yes, Cynthia, you have something for us?
No.
Okay.
But you can you can resend the link for the assignment.
Okay, the link, the assignment link is actually within that document. So maybe I can just share the document before we leave. Let me just present the document, sorry, to us so that I also take us through that of what we expected to do. Please unmute, Cynthia. Sorry, mute. Thank you. So guys, here's the document and here's the challenge. So it is actually the first challenge we're giving out. That is some technical challenge. So you've been tasked to write a simple banking software to perform the following operations: register a new account, update account information, delete account record, deposit money to that account, withdraw money from that account, transfer money to another account. So all these, you should be able to do them in Rust. Like this program should be written in Rust, and you're advised to be as creative as you can. So you're at liberty to get as creative as you can be to craft your robust solution. And then once you're done and you've pushed your project to a GitHub repository, in this case, your GitHub repository, you're going to submit your details right here. There's a link that has been provided right here. If you can't follow that, you can just copy this. You can simply copy that on your browser and you'll be able to get that form and be able to submit your details right there. So I really hope that is clear, right? I really hope that is clear.